This is our planet. It's covered with vast oceans, massive mountain chains, deep valleys, and enormous deserts. And yet, we know it was not like this for most of its existence. Continents drift across the globe. Oceans rise and fall, and entire mountain ranges are lifted or toppled over. Yet despite these dramatic changes, life always seems to find a way to not only survive but thrive in virtually every environment. But there was one era that stands out as being the deadliest ever, a time when Earth almost killed all life in its most bizarre form. Welcome to Paleologic. Today we will explore Earth in the time of Pangea, the deadliest era ever. Pangea, meaning all Earth in Greek. It's a supercontinent that began assembling around 335 million years ago during the late Paleozoic era. For tens of millions of years, various landmasses slowly fused together into one giant jigsaw puzzle. This process was driven by the movement of Earth's tectonic plates. At first, these were much smaller than they are today, but as they collided and joined together, they formed larger plates, which eventually created the supercontinent. Although the assembly of Pangea was a slow process, it had profound effects on Earth's climate and environment. Prior to the formation of Pangea, multiple smaller continents existed, each surrounded by their own separate oceans. This resulted in mild climates worldwide because ocean currents were able to moderate temperatures. However, with the formation of Pangea, a large, dry, continental interior emerged away from the moderating influence of the ocean. This led to the formation of vast deserts and the development of a more extreme continental climate. Furthermore, the supercontinent's size caused the formation of mountain ranges as a result of the collision of tectonic plates. These mountains acted as barriers, disrupting the flow of warm water from the equator to the poles. As a result, a colder, drier climate developed in the interior of Pangea. While the coastal regions experienced warmer, wetter conditions, these climatic changes had significant consequences for the distribution and diversity of plant and animal life. As the supercontinent grew, new species evolved to adapt to the drier conditions in the interior and the lush environments near the coast. For example, plants with tough, waxy leaves to prevent water loss thrived in the dry interior, while ferns and other moisture-dependent plants flourished near the coast. These changes also affected animals, leading to the diversification of species, as they adapted to different habitats within and around Pangea. However, the formation of Pangea wasn't just about continental drift. It also played a key role in triggering one of the largest mass extinctions in Earth's history. The Permian-Triassic extinction event, also known as the Great Dying, occurred roughly 252 million years ago at the end of the Permian period, which itself was the last period of the Paleozoic era. It marked the beginning of the Mesozoic era, which gave rise to the dinosaurs. This event is believed to have been the deadliest in Earth's history, with estimates suggesting that it wiped out 70 to 90% of marine species and 70% of terrestrial vertebrates.
Oh, wait.
But what triggered such a catastrophic event? One of the leading theories is the formation of Pangea. As the supercontinent assembled, vast quantities of rock were uplifted, creating mountain ranges that dwarfed even the Himalayas today. These mountains acted as barriers to ocean currents, disrupting the global climate and causing major shifts in temperature and precipitation patterns. For instance, the mountain-building process released huge amounts of heat and moisture into the atmosphere, leading to global warming and changes in rainfall. Furthermore, the formation of deserts in the interior of Pangea, caused by the rain shadow effect, may have led to the evolution of plants that released large amounts of toxins into the atmosphere. Another theory points towards volcanic activity as the primary cause of the extinction event. Massive outpourings of lava known as flood basalts occurred in what is now Siberia, releasing huge amounts of greenhouse gases and toxic substances into the atmosphere. These eruptions are estimated to have been about 2,000 times more powerful than the 1815 eruption of Mount Tambora in Indonesia, which caused a global cooling effect and food shortages. The Siberian traps, as these volcanic events are known, are dated to be around the same time as the mass extinction, suggesting a possible link. A third theory involves the release of methane from the ocean floor. As Pangea formed, ocean water may have seeped into the cracks of the seafloor, reacting with rocks to release methane gas. Methane is a potent greenhouse gas, and its sudden release could have caused rapid global warming, leading to the mass extinction. Additionally, the decomposition of organic matter in oxygen-poor deep waters may have also contributed to the release of methane and other harmful gases. Regardless of the primary cause, a combination of factors likely played a role in the severity of the Permian-Triassic extinction event. The formation of Pangea, volcanic activity, and ocean methane release each contributed to a changing climate and ecosystem that life on Earth had never seen before. Many species were unable to adapt to these rapid changes, leading to their demise. However, amidst this ecological upheaval, life found a way to not only survive, but thrive. The organisms that did survive the mass extinction were primarily small, short-lived, and generalist species, those that could adapt quickly to changing environments. In the oceans, small fish and marine invertebrates dominated, while on land, early reptiles and amphibians flourished. These survivors inherited an Earth transformed, one that was primed for the rise of dinosaurs. After the mass extinction, Earth began to recover. Over millions of years, life repopulated the planet, although never exactly as before. New species evolved, filling the ecological vacancies left by the mass extinction, and ecosystems began to stabilize. Towards the end of the Triassic period, the supercontinent Pangea began to break apart once again, setting the stage for the Jurassic period and the rise of dinosaurs. Pangea's breakup led to the formation of new ocean currents and the mixing of previously isolated populations of animals and plants. This mixing of life forms resulted in the formation of new species as populations adapted to their new environments and interbred with other species. Additionally, the separation of land masses created isolated habitats that allowed for unique evolutionary pathways, leading to the emergence of new species not found elsewhere. For example, the breakup of Pangea led to the formation of the Atlantic Ocean, which became a barrier between the land masses of North America and Europe. This isolation allowed for the evolution of distinct species on each continent. Similarly, the splitting of Gondwanaland, which included present-day South America, Africa, and Antarctica, allowed for the diversification of species in these regions. The isolation of Antarctica led to the evolution of unique plant and animal species, including the ancestors of modern penguins and seals. The effects of Pangea's breakup were not limited to the natural world. It also had profound implications for the distribution of early humans. As the supercontinent broke apart, humans and their ancestors were separated into different regions, leading to the evolution of distinct human populations. For example, the migration of humans into Europe is believed to have occurred after the formation of the Atlantic Ocean, which separated the land masses of Europe and the Americas. Despite the challenges posed by the breakup of Pangea, life on Earth continued to flourish. The Mesozoic era witnessed the rise of dinosaurs, the diversification of mammals, and the evolution of birds. The Cenozoic era, which began around 66 million years ago with the extinction of the dinosaurs, saw the rise of primates, including humans. Each of these eras has been marked by significant events in the history of life on Earth, demonstrating the resilience and adaptability of life in the face of environmental change. In conclusion, the formation and breakup of Pangea were pivotal moments in Earth's history. They shaped the planet's climate, environment, and the distribution of life. While the assembly of Pangea led to mass extinction and environmental upheaval, the subsequent breakup of the supercontinent paved the way for new species and the diversification of life. From the evolution of dinosaurs to the rise of humans, the legacy of Pangea continues to shape the world we live in today. Thank you for joining us on this journey through time. If you enjoyed this video, please don't forget to like and share. Your support helps us continue exploring the fascinating history of our planet. And if you haven't already, hit the subscribe button to stay updated on our latest releases. Join us next time as we uncover more secrets from Earth's ancient past. Until then, keep learning and stay curious.